Okay, so the next section is called 7.6, which is factoring high degree polynomials. By high degree, they're talking about things that are bigger than squares that we don't have a technique for. We had difference of cubes, but this doesn't look like a difference of cubes or a sum of cubes. This just looks like a polynomial chain where the highest degree is 4. And of course, we talked that these can keep going out, so there could be, an x to the 5th, and so on and so forth, going back to x to any high degree. And so we ask ourselves, is there a technique or some type of device that will allow us to factor these high degree polynomials? There's actually two. They're kind of the same thing, but just a little different. And so we're going to take 2 days, and today I'm going to show you the first technique. The first technique is the first thing I want to show you guys is the factor theorem, which says that x minus c is a factor of the function p of x if and only if p of c equals 0. And what that is saying, and all that's saying, is just a fancy way of saying if you have some function, say f of x equals x plus 2, what makes this 0? And you guys would tell me that, well, f of negative 2 makes this function come to be 0. Okay, so therefore this would be, negative 2 would be a factor of this function. Okay, so we're looking for c's, or critical numbers, that will make the polynomial 0. Let's lead into then, how do we figure this out? Okay, so here's a polynomial, x cubed plus x squared minus 8x minus 12. And we're going to ask ourselves, what are the factors of this? How we find that out is we look at this last term, and we see it's negative 12. We ask ourselves, what divides negative 12? Okay, and we literally have to make a chain of things that divide into negative 12. So we'll start with 1. However, there's negative 1 also that could work. So we need to put plus or minus 1. Okay, 2 works, but of course negative 2 could work. So we have to say plus or minus 2. Plus or minus 3 is a divisor of 12. 3 times 4 is 12. Plus or minus 4. Plus or minus 6. And then plus or minus 12. And we sit there and say, that's a lot of factors. And literally, we have to go through all of these and find out which one makes this turn into 0. So we'll start with p of 1. So p of 1, and I'm going to just insert 1 for each term of x. 1 squared minus 8 times 1 minus 12. This will be 1 plus 1 minus 8 minus 12. This will be 2 minus 8 minus 12. At this point, if you can notice that it's not going to equal 0, well then go ahead and just say, hey, this doesn't equal 0. So positive 1 cannot be a factor. Okay, so now we got to go back and we got to try negative 1. Okay, so let's try negative 1. So p of negative 1 equals negative 1 cubed plus negative 1 squared minus 8 times negative 1 minus 12. What does this give us? P of negative 1 equals negative 1 plus 1 plus 8 minus 12. This is 0 plus 8 minus 12. At this point, I know it won't equal 0. So p of negative 1 does not equal 0. Therefore, negative 1 is not a factor. Let's keep going. 2 was our next thing on the chain. So we say p of 2, and that equals 2 cubed. 2 cubed plus 2 squared minus 8 times 2 minus 12. This equals 8 plus 4 minus 16 minus 12. I can already tell you from here this does not equal 0. So 2 is not a factor. Let's try negative 2. Negative 2 cubed plus negative 2 squared minus 8 times negative 2 minus 12. This will give us negative 8 plus 4 plus 16 minus 12. This gives us negative 4 plus 16 minus 12. This gives us negative 4 plus 4. So P of negative 2 equals 0. This means that negative 2 is a factor. The way we represent that is saying x plus 2 is a factor. Okay? To check to make sure you're saying this right, if you put negative 2 in here, this should become 0 also. Or if you want to think of it this way, you say x plus the opposite of whatever you got here. So if this was positive 2, you'd say x minus 2 is a factor. But since we got negative 2, we're going to say x plus 2 is a factor. Once we establish that x plus 2 is a factor, what we do is we complete this division. So we say the original polynomial, x cubed plus x squared minus 8x minus 12 divided by our factor, which is x plus 2. You can use any division you guys want here. So I'm going to use synthetic because that's how I feel comfortable. So 1, 1, negative 8, negative 12. I do an underbox, and I do a line and arrow, and I take the opposite of this guy. So this will be negative 2. So negative 2, or sorry, this is just 1. So negative 2 times 1 is negative 2. I add these. This becomes negative 1. Negative 2 times negative 1 is 2. I add these. This becomes negative 6. Negative 2 times negative 6 is 12. I add these. This is 0. I have no remainder. If you get a remainder, it means we've done something wrong and we need to go back and try again. On all of these problems now, we should be getting no remainder. So I need to rebuild this. I started with a degree 3, so I know this has to be a degree 2. So this is x squared minus x minus 6. We're almost done. From here, we need to recognize that this is only part of the answer. We really need to present our answer in the factor form that they're looking for. So what we say is that x cubed minus x squared, or sorry, plus x squared minus 8x minus 12 equals our factor, x plus 2, and whatever we just discovered, which was x squared minus x minus 6. Okay, so from here, we are almost finished. We need to check to make sure this isn't factorable, which in this case it is. So this is x plus 2 times x plus 2 times x minus 3. And this would be our final answer. These are all the factors of the polynomial x cubed plus x squared minus 8x minus 12. Okay, let's do one more for practice. This is p of x equals x cubed minus 2x squared minus 14x plus 3. I chose this one because this is nice because, well, there's only a few things that devise 3, and that's plus or minus 1 or plus or minus 3. So let's check these. We'll check with positive 1. It's always a good place to start. 1 cubed minus 2 times 1 minus 14 times 1 plus 3. This is 1 minus 2 minus 14 plus 3. This is going to give me nowhere near 0. So let's move on. Let's try p of negative 1. P of negative 1 equals negative 1 cubed minus 2 times negative 1 squared minus 14 times negative 1 plus 3. Oh, slide that over for you guys. All right, this will give you negative 1 minus 2 plus 14 plus 3. I can already tell you this will not equal 0. So let's move on to another now. Negative 3 equals negative 3 cubed minus 2 times negative 3 squared minus 14 times negative 3 plus 3. There it is. Negative 3 cubed will give you negative 27. This will give you positive 9. This will be minus 18. This will be plus 32 plus 3. 27 minus 18 is nice enough to come to negative 35. 32 plus 3 is positive 35. Look, we found what we wanted. P of negative 3 equals 0. To represent this as far as the polynomial, we'll say that x plus 3 is a factor. Now that we've discovered a factor, we can go ahead and come back to our polynomial and look at the division process. So we're going to ask ourselves, what is this polynomial divided by our factor, which is x plus 3? Again, I'm going to use synthetic. That's where I feel comfortable. 1 minus negative 2, negative 14, and 3. Box under, line, arrow, opposite factor. Negative 3 times 1 is negative 3. Add these together, you get negative 5. Negative 3 times negative 5 is positive 15. Add these together, you get 1. Negative 3 times 1 is negative 3, which gives me 0. I have a 0 remainder. That's what I want. Good. Let's rebuild the polynomial. I started with an x cubed. I should retract back to an x squared. Minus 5x plus 1. However, we're not quite done. We want to represent our results like a mathematician would, showing our skill here. So we'll rewrite the polynomial. X cubed minus 2x squared minus 14x plus 3 equals, we'll start with the factor, x plus 3, and then with what we found in our division, x squared minus 5x plus 1. Before we're finished, we need to ask ourselves, is this divisible? Or sorry, factorable? And right off the bat, is there anything that will add to 5 but multiply to 1? No, not that I can think of. And if you really want to double check, we could run the test for prime, which says that 5 squared is 25 minus 4 times 1 times 1. This will give you 21 as an answer. 21 is not a perfect square. Therefore, this is not factorable. So this will be our final answer. Okay. If there's questions, comments, let me know, and we'll talk more about this tomorrow.